All right, so now we'll have a recording of it. All right, so what does like terms mean? Two requirements in order for them to be like terms. Well, again, not really a base. Same variable, but what else has to be true about that variable? Can I do that and make that in anything? Same variable. Can I? Yeah, in order to combine like terms, and combining means you can add them or subtract. So let's talk about that. There is a huge difference between combining them, which is adding or subtracting them, versus multiplying and dividing. Because we just did a lesson that says I can do something with this. If I'm multiplying those two terms, I can do something. What can I do? Got a quiz on it. So. There's a 1 there. We can add the exponents, and that equals y to 4. So I can do something with that. I cannot do anything with this. I don't know what y is, so cubing y, multiplying it by itself 3 times, changes the value and means that I can't just add it to this. There's no way to combine those terms. You just have to leave it just like that. So what a polynomial is it some kind of an expression that involves multiple, I guess monomials they call them in the book. I'm not super concerned about that. You just need to understand. I'm not even really concerned about, like, some of the problems are going to have you put them in the correct order, the way it shows. Hopefully you know that. It'll have you, what else does it have you do? Oh, it asks you what is the degree of the polynomial, which we're going to go over, but I'm not going to quiz you on any of that. I doubt you're even going to see any of that on. These quiz grades better be good. So much phone usage in this class and next class. So this, just as an example, the correct way to write a polynomial is with the highest degree. That just means the biggest exponent. So this is a 3rd degree polynomial. It's got a 3 as the exponent. I think 3rd or 4th, I don't even know. Again, I'm not worried about you learning it, but you do need to know what order to write it in. You would never write it like this. You need to know that the highest exponent, the largest exponent, is the lead. If you have 2 different variables, again, the highest exponent is the variable you would lead with. Doesn't, like, a lot of times we always see the x's first, but that's normally because it's has the highest exponent on it. But this is where you get the degree from. We'll see when we do some problems if it's. Now I'm questioning myself and saying, is that actually considered 4th degree because it's a constant? But I think a constant is a 0 degree, so that would be a 3rd degree. This constant is actually 0 degree. So if we just had a number added on, if you're not sure what in the world I'm talking about, I put the number 3 at the end. Well, the number 3 doesn't have a degree. It's like a 0 degree. Yeah, I have one already made up. It's probably better for you to go now while we're doing very, very base review stuff. Yeah. I don't have to names, so I'm just making it up. Something like that. Just the D, I guess. Let's see. I'm doing a super fast version of some of the problems you're going to do. So degree, putting it in the right order. We'll come back to 1 through 4 in a second. So you're doing this for problems 5 through 10. The highest exponent would be the first term. And you work your way down. Anything that is just a number will always be last. So anything that is just a number, the constant basically is always the last term. If there's multiple constants, you add them together first, then you make whatever the answer is the last term. Oh, one other thing about a polynomial, you cannot have a negative exponent. If it's a negative exponent, then we don't consider it to be a polynomial. So that's another thing. A negative exponent could also be in the form of this. Because remember, there. That's actually not a polynomial because we consider that to have a negative exponent in it. Even though we don't see any negative exponent, y being on the bottom is like saying it's being multiplied times y to the -1. Because remember, if we had a negative exponent, it meant we had to move everything to the bottom. So this is like saying, and again, you don't really need to understand this, just understand that basically if you have a variable on the bottom, it's probably not going to be a polynomial. Some of it in the, so that's like saying times y to the -1. That's why, even though we didn't see a negative in it, it was considered to have a negative and therefore not be a polynomial because it would be saying the same thing as that. And again, I'm not super concerned about it, but when you hear me say these things, if you don't know them, remember them, you're going to be kind of lost. Standard form, again, that just, so now I'm looking at like 11 through 16. That just means write it with the highest exponent as the first term, and then work your way back from that. If it's not a polynomial, you can't do that. So like 13 looks like it's not a polynomial. Actually, no, that is a polynomial. Number 6 is a polynomial. It's a 0-degree polynomial. But as long as, well, yeah, I guess technically, yeah. I consider all of them polynomials, but yeah, technically you should be saying binomial, monomial, like if it's just one term.
And then that just,
So technically, I forgot there. I didn't really read the question honestly. Yeah, so the last thing, so they're all polynomials, but you can more, it's like saying, well, a square is a rectangle, because it is, but it's a specific kind of rectangle. It's a rectangle where all the sides are the same, but it's still a rectangle. A monomial is still a polynomial. It just isn't a polynomial with only one term. Binomial is a polynomial with 2 terms in it. So it's still a polynomial. But again, I'm not super, we're gonna kind of, I'm assigning those to you, but I'll tell you right now, I'm not quizzing you on any of that stuff. You just need to understand it for when we start doing the problems 17 and on is what we're really. What you do need to know kind of what FOIL means. What's FOIL mean, or what? I mean, it doesn't really mean this, but we just came up with it. What's the FOIL stuff stand for? Yeah. So when you go to multiply, you can kind of use this concept. And I think visually it's actually easier to see, but. So when you go to multiply, again, all this is review, you're taking the first terms in each expression and you're multiplying those together. Taking the last, was that to me? Is that each other? Right. So you're taking the last terms and multiplying those together. Those are the ones that will normally help you identify like what you need to do when we get into factoring, at least how you can start factoring. The inside and outside is a little bit tougher, but then when you're multiplying, you'll take the 2 inside terms and multiply them and the 2 outside terms. If you have more though than just 2 binomials, I guess, if you have more than 2 binomials, then you got to do a little bit more. And I just think visually it's a lot easier to show. So we'll do that in a minute. First, we're going to do the adding and subtracting. One thing you got to understand about that, and you should be able to do all of them. Look at number. Let's just go all the way to number 24. Oh, shoot. Let's do the answers real quick. So we did what FOIL is. is it possible for a binomial and a trinomial to have the same degree? So read number 3 real quick. Read on your own, and then we're gonna answer it as class. Read number 3. See if you how much you retain from. Although actually, if you look it up in the back, you already know the answer. So if you think that is a yes, like you can have a binomial and a trinomial that have the same degree, raise your right hand. You think yes. If you think no, not possible, raise your left hand. So every hand should be up. Yes, it's possible, right hand. No, it's not possible, raise your left hand. You don't know, take yes.
Wait, what was the question?
If you think that it's possible, number 3 is a yes, basically, if you want to read number 3. If you think that's yes, that's possible, raise your right hand. If you think no, not possible, raise your left hand. What does it even mean? Who thinks I can even me explain what that means? That's what it means. So let me explain what it means, and you tell me if it's true or not. So can you have an expression that only has 2 terms? Doesn't matter what the term, well, can't have any negatives in the exponent because then it's not a polynomial. So can you have an expression that's a polynomial, but only it would have 2 terms in it, and the highest exponent is the same for both of the 2 different expressions? That's what it means. So the highest, so again, doesn't give you any other specifics. So just 2 terms. Give me a term with an exponent and a variable. So I need a number, a variable, and an exponent. Oh my God, you all said it by it. Say it again. 7x squared. So that is a monomial, which we're going to make into a binomial. I want to add that to something. Give me something to add it to. 10x. So there's a, so let me make sure, because I'm not, make sure it qualifies. So that is a binomial. It has a degree of what? What's the degree on that binomial? 2. 2. That's the highest exponent, 2. Right? So now let's try to come up with a trinomial. So again, trinomial just means it's going to have 3 terms, no negative exponents, but it still needs to have the same degree. So what could my first term be? Anything with a square. 6x squared. It could be 7x squared. We could use the same thing. Now give me a second term. We do 10x again. Now give me a third term. There's a trinomial. It's got 3 terms. Does it have the same degree? Absolutely. So it is very possible. There's an infinite number of them. So yeah, you can have, just because it's a binomial and a trinomial doesn't mean they have to have different degrees. The first term can still be the same degree in either of those. So that was a, yeah, that's possible. What about the matching? Does anybody remember there? Or you could have just multiplied it out. What was A matched up with? Now we're on 4. What does A match up with? You hopefully you know how to multiply that out if you didn't just know the automatic rule. Oh boy, I guess we're doing that one then. Because that's the main one you got to know. So if we want to multiply out 2 binomials, what are the letters? U and V? So here's where the FOIL thing comes in. I'm not even going to use the words FOIL, because again, if there's more than 3 terms in there, FOIL doesn't really match up perfectly. Just take the first term in one of the parentheses, I always say the first parentheses, and multiply it times all of the terms, not just both, all of the terms in the other one. What are you doing down on the floor? I hope you can see all this.
I can.
Right. So I take the first term and I multiply it times every term in the other side. Like That's all FOIL is saying. You're just taking one of these terms and multiplying it times every term in the other set of parentheses. I will color coordinate this first one for us, though. So my blue line. Oh, I didn't. Oh, perfect. So my blue line is going to be the first one I do. So U times U is what? Everybody knew that one. And now I say, what do I write for the U times the V? There we go. So here's the way I like to think of it. As long as you get it right, I don't care. I'm not reteaching the whole lesson on this. I like to think of this as a positive times a negative. That subtract V to me is negative V. I think of it as this, plus negative V. So positive times a negative gives me negative, or in this case, now that I'm writing an expression, it's subtract UV. Again, you have another way to do it. As long as you come up with the right answer, like as long as you get to this point, fine. Now we're done. We've multiplied this times everything we can multiply by in the other parentheses. I move on to the next term. This term times every term in the other parentheses, which in this case is just 2, but you'll see some of the problems have more than 2 in them. So I have positive V, positive U, plus VU. Right, just all this is saying is I'm just multiplying them together. This, by the way, just to really go backwards, that's not math. We didn't do any math. Like I told you, we can't combine different letters. Like these are not like terms, right? We didn't combine them. We just took away the math symbol. That's just saying we're multiplying. We didn't combine them into one number. All we did is just remove the multiplication symbol and just call it UV. That's why combining is different. Combining is actually taking two things and making it one thing. This is just removing the multiplication symbol. It's still two separate things. So now positive V, negative V, what's that? Back V squared. So which one is it? Matches up with one. Okay. So you got A, B, C, how many? It's none of them, right? That doesn't match up with any of them, does it? What have I not done?
Simplify it.
You got to understand U times V is the same animal as V times U. Because we can always flip the order of two things that are being multiplied together. 2 times 3 is the same thing as 3 times 2. 6 times 9 is the same thing as 9 times 6. So these are like terms, even though, again, they have the same variables and they have the same exponents. Doesn't matter what order they're in because they're just being multiplied together. So that cancels with that. So that is the answer. That's what it matches up with. And there's a shortcut to it. Anytime you have a plus a term and a subtract a term, because in the book it's plus and then subtract, this is always what you're going to get. The two inside terms are always going to cancel out. So really all you have to do is multiply the first two terms and the last two terms, and you're going to have subtraction. I don't really like teaching the shortcuts and memorizing stuff, because you can always get to it by knowing what you're doing. You'll get there if you just understand how to do the FOIL. It might take you an extra 30 seconds to go through the whole process, but if you try to memorize stuff, you're gonna get stuff confused and possibly just forget it altogether, what the memorization trick was. Again, if you're great at memorizing, I'm not going to stop you from memorizing, but you don't need to memorize. So that was the answer to that one. They don't move. Okay, good. Go ahead. Oh, should I do one more? Well, finish. Just, we're gonna be doing all of these. So again, I'm not gonna teach tricks. If you want to come back and look at those multiple choice ones, I'll just tell you, B matches up with 3. Oh, I see why you're saying 1. So B matches up with 3. Because again, now we don't have subtraction in the middle. Actually, it wouldn't even matter if we have subtraction in the middle. The 2 inside terms are basically going to just be the same thing. And then when you combine them, it's like multiplying them by 2. If you do the FOIL method and say U plus V times U plus V, you'll see which one it matches up with. Same thing on C. Just do U subtract V times U subtract V. You'll see that it matches up with V, the 5th one. So C matches up with the 5th option. U plus V, well, that one's got to match up with the only one that's all positive. So that matches up with 2. And then E matches up with 1.
Wait, what is C?
E. C matches up with 5 or V or whatever you want to call it. All right, again, all of those just come from what we're about to do. So now skip down. Oh, crap, we got to do the other ones first. Look at 24. I'm not going to do the other ones. You can do the other ones. 24 is probably the hardest, I guess, more difficult. So I'm just going to go straight to that. Oh, wait, hold on. Actually, I guess they're all pretty similar, so I'll still do 24. There's really not a lot you can combine in 24, now that I look at it. I will talk about how to use the parentheses though. So everybody look at 24. I'm only doing this one. You should be able to know how to do all of them after this. So plus, what is it? Y squared of 1 plus 3y subtract 7. All right, so here's your first thing to remember. If there is a plus sign in between, like expressions that are in parentheses, then you don't need the parentheses. So for example, there's a plus sign in between those expressions in parentheses. And I don't need parentheses. Like this is just the same thing as this. I really don't even need these parentheses in the front either. I'll get rid of those in a minute. So I could say this. I could just say y squared plus 1 plus 3y subtract 7. I don't need all of the bracket stuff and all of that. That is just worthless notation. Now I do need the outside brackets, but that's because of this negative. This is what tells me I don't need the inside parentheses. So again, this, I need something after the subtraction sign. So that's when it becomes important. So somehow make yourself a note if you're not following me. If you have a subtraction sign, you have to keep the parentheses after that, if there are some. And I'll show you why in a second. But inside, if I have a plus sign, I don't need these parentheses and I don't need these parentheses. Now, here's why I need the subtraction sign. I'm sorry, the outside parentheses. Here's why I need these, basically. This subtraction sign is subtracting all of this. Like this is a number. I don't know what number it is, right? But I am subtracting this entire, use that, even better. I'm subtracting this entire number, whatever it is, again, I don't know what it is, but I'm subtracting that entire number from this y3 plus 1, y to the third plus 1. I can't just subtract the y squared, or I can't just, I mean, that's the only one kids normally only subtract, but I've got to subtract the whole thing. So that's why we apply the rule and say, well, if I got to subtract this whole thing, if it were one number, I would subtract that whole number. But yet I don't know what that number is, so I can't do that. Because again, I got a whole bunch of variables and stuff. That's why we have to distribute the negative sign or the subtraction to every single term. Because I'm subtracting all of those, like all of those are part of one thing. So I've got to make it, and again, I'm going to leave them in there. I don't need them. I need to say I'm subtracting the y squared. I'm subtracting the 1. I'm subtracting the 3y. And I'm subtracting -7. So I'm distributing. It's kind of like when you do the distributor property with a number out in front. You're distributing that number to every single term inside the parentheses. We're distributing, and you could think of it this way if this makes more sense. That's a -1, which technically it is. So you're really saying -1 times y squared, -1 times 1, -1 times 3y, -1 times -7, because that end part is going to change to +7. I now hopefully realize I don't need the parentheses here. They don't affect anything. So this is the expression you would get after you distribute everything and get rid of the parentheses. Now you just look for like terms, which there really aren't that many. What are the like terms? Same variable, same exponent? Not like terms.
So 1 and -1.
And
7.
yeah, just the numbers. That's all you can combine. So you'll have y cubed, subtract y squared, subtract 3y, and then +7, it looks like, because the ones cancel out with each other. So +7. Y cubed, I guess I could write it from y cubed, subtract y squared, subtract 3y, +7. Well, that's the only one I'm doing out of that whole set. Just be careful. If there's no negatives at all, then you just add everything together. There's no, I don't even know if they gave you one like that. It doesn't look like they gave you one where there's no negatives at all. But number 22, you could just basically remove the parentheses there and combine. Anytime there's a plus sign in between, it doesn't affect anything. You don't need the parentheses. So you guys can finish that up. Actually, go ahead and do that. We'll give the answers out. So I'll give you. Probably will take a few minutes. But I'll give you like 4 or 5 minutes, and then we'll call out a couple answers and we'll move on. You can, if you feel like you got it down, and you can be done with that.
You want to do a certain numbers?
Nope. I want to do as many as you need to be comfortable. I would do the odd ones first, so you can check your answers. And if you're getting all those right, then you probably don't need to do the even. That's why I picked it even.
Here you go.
17 is what I just did. There's a subtraction in between. So you need to do what I did with the subtraction. So what's follows it. So you don't do anything with the first expression, 6x plus 5. You can just go ahead and get rid of those parentheses immediately if you really wanted to. So again, do the odd ones, check your answers. If you didn't get them right, then you may want to do the even ones, and I'll have to work some of those out or check your work. I'm holding some. Really asked to go back. Nope. Nice. I could have sworn somebody asked and I held them, but no. You're following? Maybe that. Yeah, you guys can check answers. You don't really need me to check answers for you. You just said that. We just said that. What's this? She's over here.
What are you gonna grade on tests? The night for them?
I feel like it.
I've been looking at the past.
I already spent like 6 hours grading. Students.
Yep.
Yep.
Can I drop my paperwork off to where to?
What do you want to do on that? But if we get through all this, yeah, I'm doing it section by section as we go. So let me start the next section. That we get more time to work on.
Okay.
Today, oh, I did write 8:31. Oh, football game, if you didn't hear, was moved to tomorrow. Because of the rain, I guess, or logistics. Game. No.
That's stupid. So I understood this right then. I was so confident.
Is that you that said you understood the second one?
Yeah, I understood it.
Somebody said it, and then they said, if I can get it, anyway.
I Yeah. Take it. Well, I get like really
Hey, Martin.
confused on like so negatives and like having this. If it, that's when it's like, when I combine like terms, would that's what I just combine these or would I just subtract it?
You think that sign outside of that?
You can put it inside.
You're not coming back?
Negative 8x plus
A
negative.
long time ago, yes. Cool. Thank you.
Probably out there, maybe out there. So how do I get there?
You go outside. You go straight.
Past administrate, yeah, it's outside, like through the front of the school, basically, and it's on the right. I think.
So. No. When I subtract it or when I add it together.
You're solving, this is not solving, you're combining. You don't subtract 5 underneath and then subtract over there, you just add them together.
That's what I'm asking.
So it's just what's plus 5, what's positive 5 plus negative 15.
It's just this. That's the answer. I got it. I did it. I did it. This would be, so that, after that, I went.
Yeah, but you can combine.
Yeah, that's what I was doing.
No, that's not how you solve. You're trying to solve. You're getting solving confused with combining. You just need to say, what is plus 5? Subtract 15. You got a calculator and you put that in a calculator, what would you get? 5 subtract 15.
Rearrange.
Hence.
Negative. So those two numbers become negative 10. That's combined.
Oh, so you're telling me that I
Don't
just.
say
I just
subtract
added
5
them.
underneath and then, if you got negative 20, right? You did it. You don't do it that way. You just say, okay, I have these two numbers. I'm just gonna add them together.
So what's plus 5 minus 15? That's what it was.
No, one's positive, one's negative.
Yeah, so 5 minus 15.
Oh, wait, yeah. So it's that-
So it's 6 minus 8, 6x minus 8.
If they're both X's, they're both X's?
Yeah.
Okay, then yeah.
He was missing.
If they're both positive, it's 14. If one's negative, then you gotta figure out what they.
So it's. It's this. Hold on, wait.
If that's odd, you got the answer back.
I can't find the answer in the back.
It's the gray pages, so you see
I
how,
can't find.
see, look. Gray, see how gray.
A31. It's not gonna, it's
Basic.
giving me like a whole different thing than we're not even.
What number is that? So the answers are on, not that this helps, but it's A9 in the back.
Yeah.
Which number?
A31.
That's 25? 23? Number 17.
Oh, 17.
Oh, 17. There it is.
But the 2 was supposed to be negative,
You should have negative.
but it wasn't negative.
Well, then you did it wrong, because it was.
You told me all I had to do was just.
No, I said you
This
add the
one is
two
it.
number. I said if one's negative, you gotta figure out what the answer is. So apparently one was negative. I said if they're both positive, it's just for teams. If one's negative, then you gotta figure out which your answer. Apparently 8 was negative
Yeah,
and 6 was positive.
yes.
Then positive 6 plus negative 8 is 13. You guys can use calculators if you're struggling with how to do positive and negative numbers. Right?
Yeah. And then if it has the.
Scratch that.
If it has a plus sign.
Do number 20, scratch that, do number 20. 22 is actually easier than. I'm listening, go ahead.
If it has a plus sign in the middle of the parentheses, I just get rid of the parentheses.
Yeah, if there's a plus in between the binomial or the polynomials, then yeah. Oh.
But how does 4 plus 7 equal 9?
Don't tell me we're struggling. This is the easy part. We haven't even gotten multiplying.
I have trouble like with adding.
Math.
Adding negative positives like. I just like.
Money.
I mixed
Money.
them up. I got see that negative, that 4y squared plus negative 7y squared was 9.
Did you?
It did.
You did 4x squared is x minus. Think about money though. If you ever have trouble, I mean, you have capital.
Yeah.
6 is the answer for 19.
Yeah, well, it's 3, negative 3y
Oh,
squared.
plus
Yeah, it's negative 3y.
Plus
squared.
I got you. What?
Like all the words. I understand.
I thought you said something about COVID. Like, what? I thought you were blaming your lack of. Done? The answer, if you have gotten to even problems, if not, you can just write it down. The answer to number 20 was x squared. Is it plus 2x? All right, so we're gonna go ahead, wrap up whichever one you're on. We're gonna move forward to the multiplying polynomials, which I think is definitely gonna be a little trickier because you're gonna wind up having two things you have to do. You multiply, so kind of the FOIL thing, but then you have to combine like terms, which is like the adding we just did. So let's go to the toughest one. We'll go to 36. So look at 36. Tell you what, I'm going to type this in because that saves me some room. Parentheses, 2x squared, subtract x plus 4. And then Oh, shoot. I said 36, x squared plus 3x plus 2.
Wait, Gil.
Yep.
You come here.
No. All right, quickly.
Okay. So,
It's odd. You have the answer to it.
well, yeah, I know, but I don't know how to put the answer. So for 23, since this, but it doesn't have the parentheses on it. The rest is gonna still get rid of the.
Well, again, what you have to do is start all the way on the inside, fix that, and then work your way out. I'll let you keep working it. You start on the farthest inside parentheses.
Yeah, why can't I just get rid of the parentheses and keep?
Well, I don't know. What's in front of it?
Minus.
No, right in front of it.
The parentheses.
Don't worry about the three out.
Negatives.
So then we can't just get rid of the parentheses. You got to take that negative and distribute it through. All right, so I'm going to show you how to do the multiplication, then I'll cut you back loose to do some more work. So look at number 36. Where's my? Number 36. Oh, no. There we go. All right. So number 36 is that problem right there. So again, FOIL, if you say first, last, inside, outside, doesn't work as well when you got 3 terms in there, which apparently I messed up the spacing on this one. So again, visually though, I think it's much easier personally. Again, maybe not for everybody. 36. So we're on to multiplying polynomials now. I'm going to take the first term and multiply it times every term in the other. I'm going to get rid of some of these lines, but visually I'm going to show you. Hold that off. Now I'm in room. I'm going to then take the second term. Keep in mind, the second term is a negative x. So when I multiply negative x times these, I need to follow the rules behind a negative and a positive when I multiply. And then I'll do this one in blue. So it's really super pretty. Oh, is it? All right. That may have been what happened why I didn't have any spaces. I hit the wrong buttons. So a little tough to see, but hopefully you get the point. You just take the term over here and multiply it times all the terms over there. And then move on to the next term and do that same thing, and then move on to the next term and do the same thing until you're out of terms and left. So I'm going to get rid of all of that. Yeah, if you want to take a picture, since you guys are still allowed to use, as right now, since you're still allowed to use phones. That works. Oh, actually, it's recorded too. What am I thinking? Recorded anyway. Do that. Didn't mean to get rid of all the stuff above, so let me do this. All right, so I'm gonna do exactly what I just showed you in the FOIL. 2x. Oh, am I gonna write all this out? I guess I will.
So wait, when you multiply.
2x squared times, and now I go all the way to the other expression, x squared. And then I'm going to say, so now I'm just kind of, I'm going to go fast. I have a positive times a positive. So I know that's going to be plus. That's where I'm getting that plus from. Well, that's again 2x squared. I'm going to run out of room on this. Let's see already. Times 3x. Now again, positive 2x squared. Positive 2 means I'm going to get a positive. So 2x squared times 2. Well, I took the first term and I multiplied it times all three of those terms. And just be careful when you have a negative, that's when it gets tricky, which we'll have now. What's in front of the x? Well, what else? Yeah, because we need a number if we're going to be multiplying times. So 1 is there. So now, do I want to just create, maybe I'll just create a separate line. Let's do that. No, you multiply anything. You can only add and subtract, basically combine into one thing, like terms. So negative 1x times x squared. It's going to look pretty similar. Now I need to be careful with my rules of multiplication. I have negative 1x times a positive 3x, which means I'm going to get, the answer will be a negative. So I'm going to say subtract 1x times 3x. And then I do this again, negative times a positive. So subtract 1x times 2. So if you'll notice, the last term in all of these is the same. Times x squared times 3x times 2. And it'll always be the same. I'm just multiplying each one of these times the same three terms over and over again. So when I do the next one, which I'll do, I guess in green. So again, now I'm on to the 4. 4 times x squared. And then again, this is positive, that's positive, so plus 4 times 3x. I'm just repeating those same numbers again. Plus 4 times 2. So again, I'm repeating the same terms again. When I do that third line. Happens when you make me mad, Daddy. Now we have to get the answers for all three of those and combine all of that into one expression. Combine all the like terms. What is 2? Still gonna run out of room probably. I'm gonna have to write small on this. So what is 2x squared times x squared? No. No. What is the rule that we should be following? Product rule. What do we do in the product rule? Just combine the exponents. That's all we can do. 2 is just going to stay 2 because this is the same thing as 2 times x squared times x squared. I can't, there's nothing to multiply the 2 times. Like there's no other constant. Now, if there was a constant here, then yeah, I'd say 2 times whatever the, I'm sorry, coefficient. If there was another coefficient, I could multiply those together, but there's not. So that's just 2x to the 4th. And then that's going to be plus. What do I get for the next one? X. No. 6x. You're over 2, girl. Your softball average is not looking. I mean, although they say batting 300 is a Hall of Fame career. You can do that over a lifetime. So you get the next one right, you do that. What's the next one? 6. You multiply. This is, remember, this is 2 times x squared times 3 times x. There's no addition anywhere in the middle. Because I'm just showing you, I just keep repeating these 3 over and over and over again. I'm changing this term, but I'm repeating all 3 of those all the way through. So what did I get? So x to the what? No. X squared times x to the first. We add the exponents. Oh boy. Okay. And just think, like you were supposed to know all of this stuff coming into this class.
It's 4x.
Now that's x squared because there's no other x, right? There's no other additional x, so I'm just at x squared. All right, you guys try to figure out the next 3 now that I did that one for you. And then you have to combine like terms. I'll give you a minute to try to do the blue and the green, couple minutes to do the blue and the green. Mhm.
X squared to negative 1x. And then probably
From going from here to here.
red to blue.
Yeah, so we use this term
Oh, wait,
first,
never mind.
and all three of those, then we're just moving to the next and the next.
Each one is each number.
And so if you'll notice, just like these repeat all the way down, we're just flipping all of these to the next term. So first the 2x and that, first 2x and that. Oh, just that one part?
Yeah.
Yes. Yep. Yeah, again, that's just the exponent rule is all we're doing in a lot of this. If you have the same base and you're multiplying, then you add the exponents. I'm gonna start filling in. I'm not gonna take a ton of time. Back to the Yep. We need those for this part. So this part would equal, I'm not gonna write the 1 in front of the variable. And where is it? Subtract. So if you want to check your math, that's the blue one. And then I'll give you another 30 seconds or so on the green one. After I walk around and see how we're doing real quick. Breaking now. Oh, wait, baby. Work on I saw you signed up.
Oh, you have to be black. It should be black.
Oh, yeah, there you go.
Wait, so it's
4 times 3x. 4 times 8.
oh, that's why I'm confused. I'm in like thirds. No, you're not.
It's my question. Reason is impossible.
The novel you're doing on Saturday?
No, so there's different. You are your own girl. It's like that. Don't think that this all together. Right. Pretty much everything else.
Or that is X squared.
Yes.
They.
Oh my gosh, what times X squared?
Or X squared.
Roll.
Or-
I'm about to do it now. I don't know. Are you talking about just for the green or for the overall?
Just the green.
All right, let's do the green. Well, you tell me, what'd you get?
Yeah. Brings square
Yep,
plus 12x.
yep.
Same.
Perfect. So that should be your green.
6.
You add them all together and sign them all together. Like you combine all that into one. All right, let's do it together. So now we're not done. Now you gotta say, okay, and theoretically, these terms would be listed out all on one line, like when you didn't. I didn't have enough room, so we're gonna have to just understand, we're just combining, we're adding together all of the terms. Do I have any like term with the 2x to the 4th? And you really will never have like terms for the first parts of the expression. Because this is the highest degree. Nothing else will be at that degree. Like nothing else will be that high. It's the highest degree in this polynomial times the highest degree in that polynomial. There's nothing else that will be that high of a degree. It's not possible. So you're never going to be able to combine anything with them. Now, the second one, normally you will, depending on whether or not they're missing some degrees in the polynomial. So do we have anything else that has a degree of 3? Yeah, we do, right? Which one? Oh, so I guess here, let's write the answer. So 2x to the fourth. How do we combine that? So you literally just like you would two numbers, you're thinking of this as a 1. So positive 6. So again, this is like having 6x cubes. Here I have 1x cubed that I'm subtracting, so I'd be left with positive 5x cubed. Remember, the number in front of the variable just tells you how many of them you have. So if I have 6 of them here, subtract 1 of them, then I have 5 of them. So squared, do I have another squared somewhere?
5x.
So I have a bunch of x squared,
Yeah.
right? So I have this one, and that one. So I have 3 of those. Again, this tells me I have 4 positive ones. Well, if I take 3 of them away, because this is subtract 3x squared, I'm down to 1x squared left. But then I'm going to add back in 4 more x squareds. So I would have, again, another 5 as the coefficient with the x squared. What about the next one? So x's, right? Well, if I have 12 x's and then I'm going to take away 2 of those x's, then 10x. And again, same thing with the last 2 terms. They'll never be like that's the lowest degree. There's only one thing that will be at the 0 degree, basically. So that would be plus 8. Yeah, that should still be accurate, even if there's a variable at the end and not a number. You can still say that. So that's your final answer. So that's not an odd problem. So you need to have that answer. It wouldn't hurt to practice that one again. Like have that answer. Go back to the book pages. If you haven't been doing this, I probably encourage you to do it. Take a picture of the book practice page, so you can go back on your own and try to do them again, and now you got all the problems worked out, especially the ones we've done recently.
No, but I was.
Okay, next, I knew somebody was either waiting or out. Was anybody or they're holding anybody after Nadia? So you'll be after Nadia, Janelle. What that do with the? I feel like I'm listening to this. Oh, sorry. All right, so you should be able to do any of the multiplication ones now. So go ahead, move forward with those. We're not going to get to the other lesson I was hoping we'd get to, the factoring, but. Let's see, I'm going to have to do. Actually, I don't even really have to do the next section. You should be able to do that. It's all the shortcut ones, but you don't need to do the shortcut. Like, you can do that without knowing what the shortcut is. I know you're on the boring thing. Oh, that's right. You can have to. All right, see you up. 31st. Thanks. What does it mean if you have parentheses next to each other? Absolutely. Remember, parentheses next to each other with no math operation in between means multiply. Just the same way it would mean multiply if you saw this. That means multiply. So if you have, doesn't matter what you have in the parentheses, it means multiply. Yeah, you should be able to do all the way through 60 now. I'm not even gonna do any of the other ones. There's a whole bunch of problems past that, which I'm not really gonna get into since this is supposed to just be a review. I already did radical, so I'm not gonna worry about that. So I really should start, I think we will start the next lesson. So practice for a little while, do a few. I'll at least introduce factoring because that's gonna take a lot longer. Guys, I'll catch up on that next class. Is it just one team today or is it multiple teams?
Everyone's there.
What are you both?
I don't remember who it is. I know where I live in this.
I always wish we both just wait on Tuesday.
Does it?
Yeah.
They're good? They're good at everything else. Down. Somebody's out, somebody's next. So keep working on that. I'll give you like 10 minutes and then I'm gonna introduce factoring real quick. Because that's gonna take more than one period. If this one took up one period, that'll be. I don't care if you work together. Remember, do the odd ones first. You can check your answers. Mm. I think it's still one spot available. If there's only one spot available. Yes. You got one of the last two. There are a whole bunch of people I gave flyers to. Oh, I just saw the list. Well, unless they signed up since I looked at it. Sent out a text earlier today. At some point, saying the building was not actually. That's the effort that I like it. That's in the back of the book.
Just going through them all. Invite them to come in.
Which one did you want me to?
Oh, I don't care about 26 and then.
Watch it is 26. Okay. That's why you were working on it. It's straight up working.
No.
Which one?
55.
55. Holy cow. Oh, 26. What did I do? 36. I did 30. I knew I had 6 in it. What did I do with my notes? You said 55. Oh, shoot, I'm on the wrong page. I was like, I didn't even teach that. Let's see, 55. Oh, that one has 2 variables in it. Yeah, shit. Well, again, same concept, just combine like terms and there's just no constants in. That's actually special.
So would this be squared?
Well, again, what would you be multiplying? You're struggling, I'm gonna make you write it out. What would you be multiplying? Write it really small, but see it, I'm hoping. would you be doing? What's the rule? Same rule we said we used in all the other ones. What's the rule you use for that? Oh, you might not have been here actually. That might be. You remember the product rule? You must have missed more than one day.
That was 2 days. I wrote everything down.
We did product rule, but yeah, product rule. You have the same base, actually, that's a good example right there. Two different bases, they're numbers, it doesn't matter. Two different bases. Go back to the problem you were asking about, we have two different bases, right? So what would that be the equivalent of? That's close, quick, there's a one on both threes, right? So you can add the one plus the one for two. Now that one you can actually then multiply out if you're getting line. And then you would say y to y to the first times y to the first is equal to y to the one plus one. You're adding the exponent. It'll be a negative term. Which one was yours? 26, you said? That's what I'm trying to figure out. 26. What have we ended up with? Okay, I get back to you. Oh. Well, here, just how we do. 4y fourth. Well, y, put it. Also, not adding the ones.
Oh,
So you y with the third. And then subtract the next.
that's it. Oh, I got it.
Yeah, the original problem.
I should say, so since there's two, then it makes it fun. Still a little bit of 3 by the 6, if it would be negative.
Absolutely, yeah. If you got two
Wait,
numbers,
it's not
you just multiply the two numbers together.
It's not squared, right? Since it's two different.
You need to write down what it is, and I think you'll see it's not squared, it's not the same term. So what you're gonna see is something that falls into this category, so that problem you're working on is this one right here. Something subtract something squared, so you'll see it can match up with this bottom thing. So we did the first term squared. This first term will wind up being squared, everything squared, so like you're going to then have two of the two inside terms both like there, and then the last term is squared. Again, I'm not concerned about you recognizing special cases. All it does is save you a little bit of time. It doesn't give you any better understanding. Actually, it hurts your understanding. So just do the long version of it. Anyone? I didn't take your phone, but I should have. Again, just make sure you bring it back.
So we're still doing the same thing.
And well, you're pretty much doing the rest of the problems now. Through I think it's 60 something maybe. You just, don't worry about special, just do it the same way we said. Yeah. Keep those up. You'll appreciate this. When Sophie used to come in for lunch all the time, I used to keep goldfish in here and she would. Leah.
I know who I got it from.
Goldfish. I don't know. I should say this thing. I would never eat them on my own.
Chips?
Not goldfish. 47. Sure. Yep, now you just lost that your base colors.
And then with I'm just gonna.
But it's just faster. And it looks better.
Obviously.
It doesn't allow you to- Yeah, see, I did, no. Now it is, look at you, now you're like, oh, now I gotta see, that's my point, as soon as you sit away. Okay. 2017.
No, 47.
Oh, 47. Oh, that's good. So what I would do personally is I would write it out. What's it mean first? And there is a rule to it, but I don't love memorizing rules. So what I would do is I would ignore this one and multiply those two and come up with an answer. And then when you come up with that answer, put that answer in parentheses and then multiply it times that. See what I'm saying? Try that, and then you can check your answer with it in the back, and if you still don't get it, let me know and we'll look. Next point. That would be 33. That's a 7 times 5 is gonna be your last times for sure. All right. There you go. So you probably did it right, just. Get rid of
You know also the stabbing at comes.
Oh, like actually in the school?
Yeah.
Oh, my goodness.
Remember, 2 kids got stabbed at country class.
Ah. Yeah, that's not good. That's blood on the ground and everything. What was that on? TikTok or something else?
My boyfriend's cousin, I think, goes there. She's seen it.
Oh, yeah, that's.
School's on lockdown. They got one kid. Apparently, he also had a gun.
Countryside is always. I would not have thought that about countryside.
Oh, really? Really?
I mean, I don't know anything about.
It's country.
Last year there was so much
Wow.
gun stuff. I think kids got caught with guns all the time.
Well, that's gonna trickle down to every school now, watch. Guaranteed. If anything happens at one public school, it trickles down to the other public school, so. I'm sure they're gonna crack down on us and all those rules that we were strict on at the beginning of the year and we're starting to relax on, they're gonna start cracking down again.
It's the fact that SRO there was just standing there, not even helping the kid.
It's the-
Because the kid got stabbed in the throat. Yeah, like, it's just something that. My mom wants to see it. She was the one who sent me, and then I told her, and she wants to see it yet.
What's scary?
I'm killing this. Mr. Gill.
Are you?
I sure do.
You want me, since I'm not doing anything from the last section, and you're just multiplying that out, if you want me to do any even ones, request even ones, so that you have the answers to send, if not, I'll just do one. Still working on it. Janelle will be back any second on me. Oh, look at that. Like on ESPN. Now the question is, do I know how to spell your name?
No.
I think I do, actually. Is that it? Pretty sure that's it. Because I always want to write EI. I always want to write it as EI, and then you always correct it.
Always be alone.
I got it right.
Yeah, so
Well, not of it happening, but like the kids on the floor, blood's all over the place on the ground. Your parents are gonna be freaking out and not gonna want you to go to school, and the whole school is gonna freak out about security and. I mean, I just expect all that to come down pipeline. Something happened at the school.
so you square for the EU.
Yeah, remember, you're adding the x. Anytime you're multiplying terms with the same base, there's a 1 on that u, so 1 plus 2 is 3.
Like someone broke.
No, I was a kid.
It's scary. It's scary. Yeah, I mean, just wonder like that. Student is gonna be indexed. But clearly they don't care. Like, wonder like what happened to that person to be willing to throw their entire life down the drain. In high school. Anybody have any requests for even number problems? Anybody even doing the even ones yet? I'll probably pick one. Are you doing some of them? Have you gotten to one you feel like you want to see the answer on yet? I'll do one of the more difficult ones, like, oh, let's see, maybe like 58 or something.
That's what I was.
Yeah, 58 already.
I was
Oh,
like,
actually, no, I didn't do 60, so any of those down there.
If I get three of these in a row, right, I have to keep these.
I don't care how many. I don't grade. If you think you got them down, I don't care how many you do. I'll do one and you can do it and check your work, but you have to be able to do the quiz. The factoring is I was gonna do factoring. Factoring is gonna be the more difficult thing. This is just following the same process over and over.
I can't get rid of these, right? Because like the parentheses, or can I?
Again, you do 40. So now it's just like this was at the beginning, front.
This,
Yeah, you could just put this at the front and then it's just like this.
that's
All
like
negative.
3, 2.
Well, negative.
Okay. Oh, okay.
Yeah, no, you just change its subtraction. You can't do that.
Yeah, you're right.
Yeah, because remember multiplication, the property of multiplication says that 2 times 3 is the same thing as 3 times 2. So we can change the order of those two terms if that makes more sense. You guys make sure that you're ready.
When are we, oh, never mind.
Quiz on this will probably not be until the Monday after next week.
Wait, it's
We're
just.
probably gonna go ahead and do one like sooner rather than later.
It's just.
No, we got a whole week of stuff that we're gonna add to it next week. So we'll do factoring for sure, which is gonna take one, and we don't have Monday, so that'll be a whole block day. And then we'll add something to it Thursday also. So there'll be 2 more lessons added on to it, factoring and then whatever's after factoring. Actually, factoring might be the last prerequisite. I don't know. Big lights, we got. What's that?
What did Miss?
No, I said Michigan.
Massachusetts.
Mass, yeah. UMass. Let's see, what is the next? No factoring is the next one. It will be a little tricky. Oh, no, there's one after that. Rational, we already did rational expression, so we'll still do that, but. Yeah, we'll still do that. That's what we're talking about. So I'm actually opening a full time. Maybe. That's right. Number 15 is. So
I hate when oh, you're the one that's doing it. You got them for like who? Gotcha. Situation. Where did you get? This, I think the last two classes. Wasn't here Monday.
She was here Monday.
What?
Yeah. Was it?
She missed one class.
I thought she was here Monday.
She either missed Thursday or she missed Monday.
Last week, Thursday?
Sure. Quiz was, did she take the quiz? I don't know.
I don't think so.
You see, how long we did quiz was. I didn't think maybe she was so clear. I probably want to do it, but I.
It's like this S cubed and then it's, you know, if it's X cubed and just X, I can't combine them, right?
Well, it depends
Wait,
on you're
I just-
multiplying or adding.
I'm adding.
Gotta be same variable, same exponent. Where? That's what I figured. People packed up. Two weeks. That's the common pay cycle, I think, the most common.
Yeah.
Gills. 47.
Oh, I was gonna do an even one. I guess I'll do it fast.
So I just write all the sounds before.
Yeah, and then you do, well, you do the first two
And
first,
then whatever I get from that.
then that all goes in parentheses times the third one, yeah. I probably should do one like that, but. Well, again, this is the easier, factoring is gonna be the more difficult. Because this, you just can follow a process. Factoring, you gotta kind of figure some stuff out. I really should have started factoring today, I totally forgot. Planned to. Actually, I planned to do the whole thing. Let's see. Oh, that's factoring. I'm still recording, I think. Oh, I hope I didn't put anything on the screen that I should have put on the screen. I'm gonna do 60. Well, you'd put the coefficient first, then the two variables. So I'm recording this, so if you've already packed up, you can watch the end of it. So if you have something with 3 sets of parentheses, so for example, some of the problems had cubed, like 2 things in the parentheses, but they cubed it, so it would wind up having three parentheses. Forget about the last one and just multiply these first. So I'd get x squared, and these are going to drop out because I'll have positive xy and negative xy. So subtract y squared. It still only has 2 things, but that's fine. So figure out what you get from this first, then put that in parentheses and multiply it times what the third parentheses was, which actually that's going to go away. So x to the 4th, subtract. That was actually a pretty easy one. So that's your final answer for number 60. It was actually pretty easy. So you can try 58. That's probably a little harder to. All right. See you on Tuesday. I'm good. 3-day weekend. Well, we gotta go to school one more day first, then have a fifth 3-day weekend. How do you guys not know that?
It's Labor Day, right? That's one of those.
That is correct. The real question is, do we need to make up the hurricane days? That's the real question.
Probably. They're probably gonna use those, patron days.
See you, Gustavo. Yeah, if we don't miss any more hurricane days, we probably won't have to make them up. If we miss more hurricane days, then we're probably gonna have to make them up.